Hello, welcome everybody. So today I'm going to show you how to connect a PostgreSQL database to Power BI desktop, and then eventually after publishing this report onto the Power BI service on Microsoft platform, how we can connect the report on Microsoft platform to our on-premises uh, Postgre server by using the on-premises data gateway. So here's the report that we have made on the Power BI desktop. Let's quickly check the dataset that we have used. So here's a dataset. From I have taken this dataset from Kaggle. Um, our contributor here has made a synthetic Amazon style e-commerce sales transaction where we have 100,000 records here. As you can see, there's only 200 customers, so and all these names are not real. It's very obvious because 200 people cannot be ordering 100,000 times. So let me show you how it looks in the Microsoft Fabric. Here's our workspace, and here's our report in direct query mode. So let's just quickly open it. Whenever I open the report in direct query mode, it is sending a query by the help of on-premises data gateway directly to our PostgreSQL server here. In Postgre, as you can see, we have 4 tables here. So the customers date dimension and product, these 3 tables are our dimension tables, and our orders table is our fact table. As you can see here, we have 100,000 rows here. Let me quickly show you the data model in Power BI as well. So here is the data model. This particular report is set up in direct query mode, so that's why you are seeing this blue line here. Let me quickly open up the same report that I have made in the import mode. Okay, so as you can see here, um, in the customers tables we have 443,233 unique customer IDs. So these are all unique customers here. In the date dimension, we have made this date dimension from starting of our records to all the way to the end when the last order has been made. Orders table, as I said, this is our fact table. So this contains 100,000 rows here. And finally, the products, we have 15 we have 50 distinct products here. So these are the ones that the customers are going to be ordering. And let me give you a quick demo and show you how quickly the data gets updated, and how the Power BI service queries our data set. So, and for the same reason, I have made a Python script here. So let me just show you that Python script first. We are going to use this script. Everything that you see here has been uploaded to my GitHub page as well, so you can go check it over there. And I have also included detailed instructions over there as well. So you can make this by yourself as well. As you can see, this is our PyApp. So this is a special login or a special connection that I've made in a PostgreSQL that we can use, that any Python script can use. And these are the queries that we are going to run. And this all is possible because of the help of our PsychoPG2 Python module. So let me just quickly give you a demonstration. Okay, so let's first go to our directory. Before that, we will activate our environment. So what this Python script does is that it is going to give us three options. One of the options is the first option is that we are going to insert a row inside the orders table. The second option is that we're going to insert another row inside the orders table. As you can see over here, this is the order ID. We have right now we have 100,000 rows in our orders table. This is the 100,001th row. This is very important because the order ID, I have set it up as our primary key. So we are going to insert a row first, then check it. We are going to insert another row, then check it, and then we are going to delete all both of this row here, and then we're going to check it one more time. And this will essentially give you a demonstration, and it will run a test basically on our system and on our connection as to how the data is updated. Okay, so let me just go to the directory, just see documents, projects, e-commerce, and this is my correct directory, insert.py. So before I hit anything, let's verify what we have here. I'm going to close this Power BI desktop window. Let's get our Microsoft Fabric loaded here. So this is the initial state, right? So right now we are at the base state where we have 100,000 rows here. So when I open this report here on the Power BI service, as you can see, our last row is the 100,000th row here. I have sorted this by order ID. So this is our greatest order ID number here. And let's just quickly verify on the PG admin 4 portal as well. I was showing you the PyApp login group here. So as you can see here, for the membership I have given, for the permissions essentially, I have added this user to the to the group role of PG write all data, PG read all data. For deletion though, you are going to have to add another permission to this PG write all data group. I have mentioned that in the detailed walkthrough instructions in my GitHub page, so please go check that. So let's just quickly verify it right now. So this is our orders table. As you can see here, we have 100,000 rows here. Let's sort them by order ID, and let's check the last orders. So let me just make it so that it's visible here. As you can see here, you can compare here and here. So data is identical. And now let's insert our row. So the first row done has been inserted. Let's reload this in our PG admin 4. As you can see, we have 100,001th row here inserted successfully. And what we are going to do, we are going to just refresh this, and you'll be able to see the data immediately being loaded here. And perfect, as you can see here, we have our 100,001th row here. So essentially what this report is doing is that it is querying straight to my database that is sitting in my local computer. And for that I have set up a on-premises data gateway as well. We will do there is a walkthrough. There are also walkthrough instructions in my GitHub page, and we'll also take a look at this later in the video as well. Let's just keep on adding another row. We will add another row here, and as you can see, another row has been added. I'm going to straight away refresh this, or maybe we can do this as well. We can go back and reopen this dashboard, this report like this. refreshing it is apparently necessary, because your last refresh is probably saved inside the cache. And as you can see here, this is visible here, 100,000 and second row, right? So, and also let's just delete everything. Let's just delete, sorry, not everything, everything above the 100,000th row, everything will be deleted. This is the query that is going to be executed on the orders table. So let's just hit enter here, and we will just hit refresh here, and as you can see here, this is loading, and perfect. You can see here that the 100,000 or 100,001th and 100,002nd, those both rows have now been deleted. So this is essentially a live real-time connection that is going on here, and that has been set up here. And in this same video, if you continue watching, I'll also give you some tips for the data cleaning, how to reduce the size of the model, how to properly connect through our on-premises data gateway, along with other tips as well. Okay. But you're most likely probably going to ask me, hey Tirth, like why are we using PostgreSQL? The reason behind that is that PostgreSQL is one of the most readily available database systems, relational database systems, that is very widely used in the world, along with MySQL. And SQL Server. The thing with MySQL is that Microsoft has their special version of SQL right here. So, and this is what is natively supported in all of the Microsoft products. For MySQL and for PostgreSQL, you need to do some extra configuration. So for that reason, I selected our PostgreSQL database, along with the fact that it is supported with our live direct query connection, as you can see here. So there are several ways of refreshing the model if when it is sitting inside our Microsoft Fabric. As you can see here, in our test dataset. So here our report is in wherever you publish the data, wherever you publish the report on Microsoft Fabric workspace, two files are created. One is the report file and one is a semantic model file. So this is a semantic model is what is storing all the data if it is in import mode, and if it is in direct query mode, it is what is saving all the connection details as to how to go query this certain database on wherever it is sitting, right? So here, as you can see, for the live direct query connection, this is all Microsoft native products, and when we scroll all the way down here, we can see here our good old Oracle database and our Postgre database are connected here. And as you can see, as I said, there are three ways. So this scheduled refresh and cache data. This all cache data is what happened before when we reopened the report from a Microsoft Fabric. It didn't go and fetch the data right away. It took the cached data what it had before, and it showed us the report by performing calculations on that. So that is cache data is essentially an automatic process. Scheduled refresh, you can set it up from over here. If you have a import mode semantic model, you can go over here to refresh, and here you can configure a scheduled refresh. The frequency of the refresh, it depends on what capacity or what kind of subscription service you have with and what kind of payment and what kind of plan you have with Microsoft and Microsoft Fabric. So it depends on that. But this direct query, if it's in direct query mode, it straight away works like immediately. It's very straightforward. And So essentially, yes, this is what we are going to use, and this is from where you can download our your PostgreSQL database server. So yes, and for setting up the on-premises gateway, as you can see here, this is another Microsoft product. So this product, essentially what it does is that it connects your on-site or on-premises or database server set up on a local machine. It sets up, it connects that to the Microsoft Fabric via encrypted connection. So whatever is sent from on-premises data gateway to your Microsoft to your Microsoft services, or essentially your Microsoft platforms, is encrypted. And here is where how you can set up your on-premises data gateway. These are all the details over here. um, additionally you can get other instructions from over here as well. This is a detailed walkthrough. And finally, like once for PostgreSQL to work properly with this frameworks from Microsoft, you'll need to add this prerequisite here. And this is the GitHub page from where you can download it. This is the GitHub page from where you can download it. As you can see, our contributor here, he has made this connector from over here. So you will need to install this in order for it to work properly. Okay, and once you set all this up, you will have to set up your cluster properly in the Microsoft Power BI service and on the Fabric, like so from here. And all these links and everything is mentioned on my GitHub detailed walkthrough, so you can go and check everything from over there. Okay, so here's our data set. It's in the CSV format. Let's open this. So this data set contains unique orders from a e-commerce website. This is basically a synthetic data set, which means that all of the entries, they are not real. They have been made to just be used as a proof of concept. And this data set contains orders, the names of the customer. As you can see, the full names are mentioned here. These are not real names, but we are going to use this as an example in our project. And it contains the product name, category, brand, the amount of quantity, the amount of product that has been ordered, unit price, tax, discount, shipping, total amount, the payment method, status of the order, along with city, state, and country. Here it says Washington DC in India. We need to fix that. And there is also the seller ID here. So let's import this data into Power Query first. Sorry, to check and see like how is the proofing, or what is the quality of the data, and what we can do with this data. So let's open Power BI first. Blank report. First of all, we're just going to save it here. Report. Okay, now we're going to get the data, text CSV, and let's just select this. So as you can see, it has fetched the encoding here by itself. Everything is done automatically. We're just going to first transform the data, and here a good habit to do here is to make a copy of the data set first. So if you make any error in the transformation, you can quickly fetch the new copy or the old copy or the origin copy very easily. So we do that by using reference. So what reference does is that it makes the copy of the original data set, and it also embeds a link to the original data set. That's to say that we can make a template, or we can make a workflow, um, or a automated workflow for each time, so that we don't have to do this every time. If the source or the if the source database has uh, this type of columns and this type of data. So for this, what we are going to do, make a new group and data model. Okay, we are going to quickly rename it. Okay, very important here, we need to set the column proofing based on entire data set, not just the first 1000 rows. Additionally, in the view section, we need to enable this option to check the health of, essentially the details of distribution statistics of the column. And as you can see, this order ID has 100,000 distinct values here. So the way how this column is in text right now, so the way how a Vertipack engine works is that it compresses the data by making indexes and using data compression techniques, and it works better on numeric data types instead of the text data type. This right now is a text column. Since we have the ORD in each record, and we essentially don't need this, we can just keep the rest of the numeric data here, and we can delete the ORD and make this column a numeric column, so that the size of our model is reduced. We need to do the same with the customer ID column as well, the product ID, and finally here the seller ID. So how should we go about doing this? We need to make a custom column like so, and we will essentially use this command here. So what this command does is that it selects only these characters from the string from each row. So only the numbers here will be taken into account, and the rest will be deleted in our new column. Okay, so it's gonna hit OK. So as you can see here, this is our new column, and it displays only 1 2 3 4 5 6 7 8. The ORD is gone, and this all should correspond to whatever is here. Okay, so now we are just going to remove this column. Before that, just copy the name, remove the column, make this guy our order ID now, and we'll change data type to whole number. Okay, so here as you can see, I've done the same with the customer ID, product ID, essentially removing the CUS and P here and changing data type to whole number. And you can actually verify this. Here I have removed the cell in the seller ID and made a custom column from that, and I changed the data type. And here as you can see on the seller ID we have 1999 unique or distinct seller IDs, and in the custom column we also have the same thing, 1999 distinct records. Okay, so we are quickly going to copy the name here. We'll remove the column. Just quickly paste it here. And the next step, what we are going to essentially do is we're going to make dimension tables, and the rest of the information we're just going to leave it here as a fact table. So basically we have 100,000 order IDs, as you can see here. We only have 43,233 customer ID. So there are a lot of customers who have made multiple orders. So what we can do is that we can make another table with all the distinct customers, and essentially we can make a relationship between these two tables and fetch the data like that, so that we save a lot of space. And we are going to do the same thing in the product ID here. As you can see, there are only 50 distinct products, and for the seller you've already seen there are only 1999 different sellers. So we can make 3 different dimension tables, and we can refer those dimension tables in this fact table, where we are going to leave the order ID here in this table. So now we need to start making our different tables. So what we are going to do is that we are going to divide this sales model into 3 different tables, wherein we'll have a fact table which will have the transactional data, essentially all the orders, all the different orders, and we'll have 2 dimension tables which will have our customers and products in them. We're not gonna make a dimension table for seller ID since there is no information given on the sellers in this model, in this data set. So before we start doing that, we are going to have to choose what columns should be in what table. We're going to do that by making a simple Excel file here. As you can see, I've mentioned here this orders table is a fact table, and this customer and product tables are dimension tables. So let's just start choosing the columns. So orders table should contain the orders date. The product name will be a part of the products table, so it's gonna omit that. Category is also product name. Category brand is also part of product. So like there is not a hard and fast rule for doing this. You just should follow your intuition, your best judgment. All this is done basically to reduce the size of the model, and make it easier for our systems to support this model, and we can also scale easily from it. So all just model optimization. So just follow your best guess. And brand quantity, going to put it in the fact table. Unit price, we should put it in the product because should be unique for each product. Discount is probably different for each order, so depending on the quantity, so it will be in the fact table. Tax depends on quantity, price and discounts, so it's different for each order, so it should remain in the fact table. Shipping cost as well. Total amount, of course. Payment method should also keep it in the fact table, since customers can have an option to pay using multiple payment methods. Order status as well. Status as well. Can move it like this slightly. City, this is a part of the address, so it should be different for each customer. State is different. Country is also part of customer table. Additionally, order ID 100% orders table, because it's going to act as a primary key. We're not going to reference this order ID to any other column, to any other table, but it's a unique identifier for each record, so we're gonna keep it in the fact table. Customer ID 100% in the customer table and in the orders table, because this is we are going to make a relationship by using this column. So here this customer ID is a primary key for this dimension table, and for this fact table it's a foreign key. Also product ID will be part of the fact table and the dimension table product. The same thing here as well. So this is a unique for this going to be unique. Product ID is going to be unique for the dimension table products, but it's going to be a foreign key in the fact table. It will be a foreign key here and a primary key here. And seller ID should be a part of the orders table, because they haven't mentioned, it doesn't have any details on the seller, so just gonna keep it. I'm not sure if we should keep it, but we can remove it later if we are not deriving any insights from this specific column. Okay, so let's start making the tables here. I'm going to shift this sales model into the staging area now, as we're going to use this query as a template for making the other queries, the other tables that we are going to eventually load inside the model. Reference first let's just do our orders table first. Order date, gonna keep customer name, we're gonna remove product name, going to remove category, we're removing as well, brand we're removing, quantity we're keeping, unit price we're removing, discount we are keeping, tax we are keeping, shipping cost we're keeping, total amount we're keeping as well, payment method also keeping, order status keeping, city, state, country, these are part of the customer tables, so we're removing that. Order ID we are keeping, customer product ID and seller ID we are also keeping in the orders table. Let's just quickly verify it with our Excel sheet here. Order date we are keeping, quantity, discount, tax, shipping cost, total amount, payment method, order status, order ID, customer ID, product ID, seller ID. Okay, very well. Just gonna remove them, remove these columns. As you can see, should match. And if you make any error, don't be worried. Here there are all the applied steps that are mentioned here. So like if you made an error somewhere, you can just hit cancel here and it will revert back to the original or the state where it was before you made a change or you made a step here. The way the Power Query is designed, like it's designed to help users and help the data engineers, data analysts. So there are a lot of neat features like this. So perfect. Now let's make our customers table. And in customer table we are only keeping customer ID, customer city, state and country, so this all is removed. 1 2 3. Okay, customer name is there, product name, category, brand, quantity, unit price, also removing discount, tax, shipping cost, total amount, payment method, order status. City, state and country are the part of the customer's details, we're keeping them. Order ID we're removing, product ID we're removing as well, seller ID also. Remove columns, and we still have 100,000, if I'm not wrong, 100,000 entries here, so we will remove duplicates from the customer ID. So now we have unique 43,233 customers, which is the same as here. Customer should be the same as here. So yeah, essentially the main reason, as you can see here, the main reason why we are doing that is that there are only 43,000 distinct customers, and on the other hand we have 100,000 records in the orders. So there are a lot of customers that are getting repeated, and each time they are getting repeated their name is also repeated, their province, their city, their state is also repeated. So by doing this we are essentially removing the duplicates here in the main table, and we are essentially saving space. Doesn't look so significant for the customers table, but for instance if you look at the product ID, there are only like 50 distinct products. So like and we have 100,000 rows here, so there gonna be a lot of repetition here. So by just mentioning the product ID and removing the product name, category, and the brand, from the orders table, we are saving a lot of space. So and also there are depending on what kind of payment or what kind of membership plan you have with Microsoft Fabric or the Power BI, what kind of capacity you have, there are certain restrictions in terms of how big of a model you can have. So this type of optimization techniques are very useful to reduce in reducing the size of the model, optimizing it, and essentially streamlining your data analysis process. So let's just quickly make the final table, which is our products table here. Proofing based on the entire data set. So see what it's supposed to have in the product table: product name, category, brand, unit price, and product ID. The rest of the columns need to go. Sort date, removing product customer name, we're removing product name, category, brand, we're keeping, quantity we are removing, also yes, unit price we are keeping, discount removing, tax removing, shipping costs removing, total amount removing, payment method also goes, state, country, city also removed, order ID is also removed, customer ID we don't need, product ID very important, we are keeping it, and seller ID we are removing it. Remove columns. So in total we had 20 columns when we started here. So let's just quickly count. 1 2 3 4 5 6 7 8 9 10 11 12 12 13 14 15 16, customer ID we are not counting, 16, 17 18 19 and 20 product, since we are not counting the product ID here. Okay, so this looks perfect. Okay, now so let's finally load this into our model, but before we do that we need to disable the loading for these tables because they are sitting in our staging area, and we are only loading these 3 tables which you've obtained finally by transforming the data and essentially streamlining our model. There is one final thing that we need to do. In the customer table we have address details for each customer, but as you can see here, sometimes in the country there are Australia, Canada, India, United Kingdom and United States, but in the state we have all the US states, right? So this is essentially incorrect, so we are going to have to make everything here United States. This is the kind of things that we run into when we make when we use a synthetic data. So we'll quickly just do that here. So for doing that we are going to use a replace value feature. Just gonna put here India, and we'll just put replace with United States. And as you can see, it has removed all the entries with India. As you can see, India is gone here. We'll do the same for Australia, Canada and United Kingdom. Okay, so I've done that same thing for the Australia, United Kingdom and Canada as well. And as you can see, we only have United States removing. But now we're going to ask, why keep United States column at all, right? We know that everything, all the customers belong to United States, but why are we keeping this column? The answer to the question is we are most likely going to need it for the map visualization, and we'll see once we use that visualization, because that visualization takes in a location hierarchy. Okay, so if we don't need it, we'll remove it later on. All right, so now we are finally going to load everything inside our model. Let's just check we have disabled this, so only these 3 tables are going to be loaded, and voila, close and apply. Okay, so Power BI has already taken it to made a relationship here based on the data, but it hasn't made a relationship here. Not sure why, but Power BI does this essentially when it finds same kind of data and same kind of column name, it makes a relation. Okay, so let's try to make a relationship here. So many to maybe want one to many. Here it says table order contains a duplicate value of 42. That's why it's not allowing the relationship. So let's just go back and check what happened. So here, gonna go back to product. So the error said problem is on the one side end of the relationship, which is the products table. And here if we click on the product ID, we can see there are like 100,000 count. This is not true. Essentially we forgot to remove the duplicates here, and that is the reason why Power BI didn't make a relationship automatically when we loaded the data. So we're just going to close and apply. Here we'll just try doing this one more time. Product ID to product ID, perfect. There is no error here. So this is like the beauty of Power BI. It's a long standing project. It has been in development since a long time. They are constantly updating and constantly adding new features, and it has developed very much, makes our life very easy. Alright, perfect. Let's just make, so this is our model. So this is set up in a star schema where these are dimension tables, these 2 are dimension tables, and this is our orders table. So, and this is how essentially the filter propagates here. Okay, so let's just make a visualization here. So let's make a put a stacked bar chart here, and let me show you how the relationships function. So as you can see here, this table and this table are related with product ID, okay, and this table and this table are related with customer ID. So let's do this. Let's put customer name on the y-axis, and let's put the total amount here in x-axis. And what this visualization is doing, what Power BI is basically doing in the backend, it's a grouping based on the customer name, and it's summing all the total amount for each time the same customer has ordered. So let's make a another visualization here to check it. Basically, let's do a matrix visualization, and in the rows let's put our customer names, and in the values we are going to put our order ID, where we're going to count it. Sorry, here we're going to count it. Perfect. So our here, so our, as you can see here, Simran Singh, this guy has ordered 599 times, and this is a amount of, this is a sum of total amount. Like in that 599 times, this is the total amount of items that he has ordered. So you get it. So this basically what is happening. Since these two tables are linked by using the customer ID, what it's doing is that it's fetching the customer name, and based on each customer name the filter is propagating like this, and based on each customer name it is summarizing this transaction table, this orders table, where it is summing all the total amounts here, and here it is counting how many times this customer has ordered. Okay, so this is how the data model, this is how Power BI works. Alright, so now we need to export the tables from here. So we're just going to use DAX Studio for that. And here, as you can see, the DAX Studio is open. Going to go to Advanced, Export Data in CSV files. Output, we're going to put it like so. I've already made the folder here, comma, separated the delimiter as comma, all the tables. And now it is exported. So let's just quickly check it here. And as you can see, it has been exported. Right, so welcome back everybody. I have gone ahead and done quite a lot of work. I was running into a lot of issues, a lot of error, as you would, because the things it they all vary from system to system. So I kind of thought that let's just pause, let's just pause the recording here, and we'll uh, record once everything is set up. So this is where we had left off. What I've done is that I have set up our Postgre server side, and I have imported all the data that we have exported from over here, and and this is essentially what we had exported. One more thing that I had done before importing all these data in in our Postgres server is that what Power BI gave me as an output here, for example, for the DIMS database, is that the format of the dates is not is different essentially from the one that I had set up for the schema in the PostgreSQL. For instance, as you can see here, the date here is in this format. So this is basically the year month day, hour second, hour minute second, and this is microsecond. So this is how the data was outputted, and I didn't quite want this ending part of here. So what I did is that I made a small small Python script here by using the pandas library, and as you can see here, what this command is doing is it's essentially removing the last 10 characters from each of this tuple essentially, or basically that's what we would call if we are to import this in Python. So this removes this last 10. You're going to have to run this same script for the date column here, um, and the first day of the month column here as well, along with the table in the table namely orders, which has been imported with a similar kind of problem. Let me just show you quickly here. Open with notepad, and as you can see here, the order date also contains 10 unnecessary characters at the end. So once you run this script, you will be left with a CSV file like this, and let's just quickly open this. I'll show you. And as you can see here, this is for the orders table, and as you can see here, the orders date has been changed, and the remaining unnecessary characters, they have been removed. Okay, so let's quickly go to our pgadmin 4 portal. So how we would import all this data over here. So you would essentially go make first of all, you'll make a data set. We'll make a database here. I have made a database called test. You'd go to schemas, then public, and then tables. You'll have to right click on the tables, create a table, and as you can see here, you can create a table and you can add the columns from over here. And this is how I have created all these tables here. For instance, in the customers table, I have set it up like this, and for the columns I have set it up like this. Okay, and the same thing for the date dimension here as well. So here is the data that I gave here, date, which doesn't take the last 10 characters that were inside the original table that we had exported from Power Query. And so that was essentially a timestamp, if I'm not wrong, but we didn't quite need that, so that is why we made that Python script here. And as you can see here, I have for the date dimension, I have set this up as a primary key. For the orders table, this is a quite rather long, rather large table as well, so it has a lot of columns, and this is how I set it up over here. And you'd ask how to import the data from over here. You can just right click here and go to this option, import export data. Toggle this radio button, toggle this switch to import mode, give the file name. Format is CSV, encoding is UTF-8, as we have mentioned in the script as well. And the last couple of things, so headers, you'll have to give the headers as yes, because the first row are our headers or column names essentially, and our delimiter is delimiter is a comma, sorry. Okay, and this is you can leave it as it is, and this is how you can import everything here. Once you have imported here, don't forget to run a test query here, like so. And as you can see here, 100,000 rows have been successfully imported here. Okay, we can check the products as well, so 50 products are here successfully loaded. Right, so you can query using standard SQL, though there are some things that are different or special about in PostgreSQL, so you'll have to check it. I have added this query .sql file to the GitHub repository, the GitHub page as well, so you can go check it, so that you don't have to struggle like me. And another thing that you are going to need is that you will need to make a login for the app. So you can like always, since this is sitting in your home computer, you can just use the admin login here, which is Postgres here, but I do not suggest that. I suggest you make I just suggest you make a proper and a different login for each application that is going to be querying and manipulating the database, so that you can track if there is an error, if there is an inconsistency. For instance, I have made this PBI connection login specifically for Power BI here, and I have given the membership, and I have assigned the role or the group role of just the read all data. So this login, it cannot edit, it cannot change the data, it cannot add any data, it cannot delete any data, right? So this is the reason why these rules are these logins are necessary. For the Python script that we are using, I have made this separate login here. So this is what these are the roles that I have assigned. I have assigned the read all data, and I have assigned the write all data here. And another special thing is that for the write all data, you will have to edit or add another special permission. I have mentioned it inside my GitHub page. I'll quickly show you here. That will essentially enable you to delete rows. So even if you give the right permission here, the permission to delete records in any of the tables is not included in this group role here. So you'll have to manually include it. Let me just show you here. So if you come down here, and here's the thing you'll have to do. You have to run this query inside PostgreSQL, and as you can see it's right here on this as well, so you can run this as well. So this is also mentioned here. This is also included inside the SQL script that I've uploaded in the repository right here. Okay, right. So, and after setting up this Postgre server, I have also created a couple of reports with the same data, and by importing the data from the PostgreSQL server. I'll quickly show you that here. So these are the three reports. This is the one where we had done all the transformation in the Power Query. Like this is also available on the GitHub repository. If you download it, you can track and go back through all the steps that I've done in the Power Query. And first I have made a report in import mode, and then I have made another report with the same kind of layout, with the same kind of everything, the same kind of data, but just in the direct query mode. Okay, so let me just quickly show you this. This is what I had made in the import mode. I'll show you the model view, and this is how I connected everything. I have also added a select measure here, which is available in the slicer here. So whatever measure you select, all the charts and everything are going to track that measure basically. And the layout and everything, this is all the generic visualizations that I have used here. You can easily do this by yourself. It only took me like 20 minutes to set this up. If you need to learn this, I suggest you to check other projects in my GitHub page. There are a couple of other reports that I have built by the help of YouTube videos, and the YouTube videos are also linked over there. You can go check that over there. And yeah, so let me show you the one in direct query mode. So this is in direct query mode, as you can see here. The data model also, there are these blue lines here because this all is set up in direct query, as you can see here, right? Additionally, I haven't used a lot of time intelligence functions, even though I have made a date table here, because the thing with time intelligence functions is that if you set those up in direct query, what happens is direct query mode, right? So when you open the report in direct query mode, what your semantic model does is that it does query folding. It converts the DAX language, or the native language of the Power BI, and it converts that language to SQL, which is understandable by the server here, by the PostgreSQL server, this SQL server, or even the MySQL server, if you are able to set it up in this framework. So query folding is what takes place, and the complex functions like time intelligent functions, those are very difficult to convert by using the query folding. So that is why those are most of those are not supported in the direct query mode. So I thought, like, let's just go with the straight through approach, as our objective was to demonstrate and make a real-time database that can be updated real time in real time. So for our purposes, this report should suffice. And I have also gone ahead and uploaded all this published all these reports, like so, on the Power BI service. Right now my email address, like, it's asking for me to log in again, even though I have uploaded from the same system. I will show my workspace here. So this is my Fabric workspace here, and it's called test here, and I have uploaded this both reports here, which I just showed you. Okay, so whenever some basics, whenever you publish a report, two files get created here. Once is the report and once is the semantic model. Semantic model, all the information related to data is saved in semantic model, which can also be reused by other mind you, though, other people as well. So if for instance, this for the semantic models in direct query mode, it saves the connection details to the data set. As you can see here, let's go to the settings and schedule refresh, perform optimization, data source, gateway, and cloud connection. So this is what is the name of my cluster that I had set up by using our on-premises data gateway tool here. So this is, so essentially this model is connecting to this on-premises data gateway that I had installed on my local system, which is in turn connecting to my SQL server. Okay. So right, so this is how it functions. So every time I open a direct query, a report in direct query mode, it sends a query straight to the database that is set up on the local machine. So there are some caching, there is some caching that takes place every time, but if you refresh from over here, you should be able to get the report to be refreshed. Additionally, that type of live functionality is not available in the that type of live functionality is not available in the import mode. For instance, the for in import mode, all the data is saved on the semantic model. So the connection is not directly made to the local database, but if you set up your cluster from over here, if you set up your cluster here, you would be able to essentially refresh the semantic model from over here. Although the amounts of time you are able to refresh are dependent on what kind of plan, or what kind of features you have with your subscription plan with the organization and with the Microsoft account, the main admin Microsoft account, but you can refresh it from over here. So I had already given you the demo with the direct query mode, so let me just give you a demo with the import mode when we refresh it, right? So let me refresh this semantic model right now, but before doing that, let me make sure how many rows we have in the orders table. Okay, perfect. We have 100,000 rows in the orders table. If we sort them descending, so as you can see, the final row is 100,000th row here in the orders table. I will hit the refresh now button here. The semantic model will refresh. As you can see, there is a process going on over here. It is refreshing right now, and just wait for it to refresh, because as I said, all the data is saved on the semantic model, so it's importing everything. Every time I hit refresh here, and as soon as I refresh the semantic model, the report also got refreshed, as you can see over here. So let me just open it quickly, and this is our visualization. This is not showing our orders here, because when I made this report before, I didn't add the orders column here. So let's just quickly change that. As you can see, like, you can edit, this is Power BI service, you can edit your reports from over here as well. Let's just add the order ID here. We're going to remove the customer ID, and we are going to say don't summarize the order ID, and we are going to sort it like so. So after sorting, as you can see here, our last row is our 100,000th row here. So now we are going to quickly test the refresh now, and let's just save this report like so, and we are going to go back. And first of all, let me just quickly check that our changes were successfully made here, and perfect. So now we are going to add a couple of rows here. So I have added two rows here. In our direct query report, it will be added automatically here. As you can see here, 100,000 and second row, 2 additional rows are there, but in our import mode report, the changes should not reflect. Basically, even if I refresh here, changes should not reflect here. But for the changes, in order for the changes to reflect here, I am going to have to refresh the semantic folder from over here. So I'm going to refresh now, and let's just wait for it to refresh here. The thing is spinning over here, and perfect. 706, the model has been refreshed, and the report has also been refreshed. So as soon as I open this, I'll be able to see a couple of rows added over here. Perfect, perfect, right? As you can see, the changes did not reflect immediately because as I said, there is a lot of caching that takes place, and that is essentially done to speed up the process basically. So if like any changes not reflect immediately, you can hit the refresh, and it should work. Okay. And one final thing that I need to show you before signing off is that, let's go to test, and here as you can see in the lineage view, you can see my PostgreSQL local server, the test database, and this local post that is showing up here. Okay. So right, so that's all there is to it. If you have any questions, if you have any concerns, you can always ask me in the comments. Thank you very much if you have watched the video until this far. Sorry I skipped a lot of steps, but I was having a lot of errors, and I didn't want to quite run around the circle, but I have mentioned everything that I've done in my GitHub repository, along with the measures that I have used while making the report in when making the report in Power BI desktop. As you can see over here, so you can even if you don't watch this video, if you like just follow through all the steps written over here in this GitHub repository, you should be able to make this and recreate this by yourself. So thank you very much everybody, thank you very much for watching this video. If you have found this helpful, please give a like, and subscribe, and yeah, thank you very much, and I hope you'd also be able to set this up, set this up by yourself, even with a different database system as well, because all the concepts they carry forward, no matter what exact database that you are going to use. If it's a relational database, it should be similar kind of workflow that you can follow to recreate this. Okay. Thank you very much everybody, take care, bye bye.